I'm funded by the Medical Research Council, which ultimately means your taxes. So you fund a number of research councils to do science on your behalf. And the MRC has a mission statement to improve the health of the nation through research. So hopefully you'll go away thinking that at least some of your taxes are well spent in terms of the research, hopefully. But MRC have been celebrating, well, they celebrated their centenary back in 2013, and this just outlines some of the research sort of highlights that the MRC have done. So Watson and Crick were MRC funded, so that's a local discovery there, structure of DNA. Hopkins you might not be aware of. He founded my department, the Department of Biochemistry, and Hopkins was the chap that really sort of began to understand sort of the importance of vitamins in terms of our diet. So he was the person that withheld vitamins from rats, then reintroduced milk and showed that they didn't get things like scurvy. MRI, magnetic resonance imaging, was an MRC pioneered. The ferret is there because ferrets are used in TB research, and I think this is the Gambia, so there's a lot of rickets research and vitamin D metabolism research. The sad thing is, 100 years on of MRC research, we're now having problems with drug resistance TB again, and we're also hearing about people in the UK with rickets sort of reappearing. So although we're 100 years on in terms of our research, we've still got the same problems sort of coming around. So who am I? So I'm a group leader at the Medical Research Council Human Nutrition Research Unit. So if you travel out to Cherry Hinton, you'll find MRC H&R. We're basically the thing that isn't R on the science, Peterhouse Science Park over there. And H&R, MRC is obsessed by mission statements. So H&R has a mission statement, and that's to improve the health of the nation by a better understanding of nutrition. I'm also a reader in Human Metabolism and Nutrition at the Department of Biochemistry, the Sanger building, so Fred Sanger being Nobel Prize winner sort of out of the department, and then I'm a fellow at King's College, Cambridge. This is not photoshopped. One of the weird things you can do as a fellow at King's is you're allowed out on any of the roofs, so that's the chapel roof there. So, my group is called Lipid Profiling and Signalling, and we aim to understand why certain individuals develop insulin resistance and then type 2 diabetes, while others are protected, and in particular how the environment interacts with that risk, with probably the biggest factor being diet. So I'm a little bit nervous. I'm not going to preach to anybody about what you should be eating. I'm a little bit nervous to see people eating, and the bad news is also drinking here. So we'll get on to the drink later on in terms of this. Is everybody happy with insulin resistance and type 2 diabetes? Do you want me to explain? So, before you get type 2 diabetes, you go through a stage where you become resistant to the action of insulin. So insulin is an important hormone that tells the body whether you're in the fed state. And what we find with people before they develop type 2 diabetes, and my talk will be focused on type 2 diabetes to a degree, they develop a state called insulin resistance. Now at that state, if we can catch people when they're becoming insulin resistant, we can make certain fairly sort of straightforward interventions in terms of their health, either be through diet or exercise, and prevent then full-blown type 2 diabetes being formed. It's much more difficult to treat type 2 diabetes, although I will show you that there are some mechanisms for treating type 2 diabetes which miraculously work, and appear to miraculously work sort of overnight. So, and looking to my host, is that the sort of right pitch? Is that the sort of talk you were expecting? Just as well, so otherwise I'd be in trouble. So the first thing I wanted to sort of make to you is about how important nutrition is. So it's got a significant impact on the nation's health and finances. So at the moment, my bosses, in terms of the research councils, have come together to put together a series of documents about how they want to fund nutrition research into the next 5 years, 10 years and 15 years. So you might not be aware of this, but at the moment we're all making pitches into government about what they should be funding. So there's a thing called a comprehensive spending review. We're all very surprised to find that we're just dealing with a single government at the moment, but we're making pitches into sort of how this has an impact on the health of the nation. So diet-related chronic diseases account for 9% of the National Health Service spend. Surprisingly, and this might surprise many people here, that 25% of all cancers are attributable to diet. So if you can change people's diets, you can have a big impact on diseases like cancer, which you might not think have a big component in terms of diet. Something that you will be aware of is heavily diet-related, is UK obesity rates. So in children, the UK obesity rates are amongst the world's highest, costing the wider economy more than 40 billion per year. So that's 3% of our GDP at the moment. And then frighteningly is that we're still talking about vitamin D and iron status and causing concern over certain vulnerable populations in the UK are vitamin D deficient or iron deficient at a period of time. So diet has a big impact. There's a cross-council vision for food, nutrition and health research. To say something slightly controversial, people aren't that interested in funding nutrition research at the research council. Nobody's here for the research council, are you? I'll get a shot. But a lot of the budget gets spent on new drugs or new genes that have been discovered in this area. Actually, you know, trying to change somebody's diet has never been sort of considered very sexy in terms of some of this research, but hopefully you'll see sort of in terms of these figures how it's important. So, I have a couple of colleagues from work as well, so I'm just sort of looking to them whether they approve my slides.
They'll be the ones heckling.
So, now, you've probably seen slides like this, but there is some really frightening statistics concerning type 2 diabetes. Is everybody fine with the difference between type 1 and type 2? So, type 1 is thought to be principally an autoimmune disease. We're still not quite sure why we raise antibodies against beta cells in the pancreas, but it tends to be a disease that affects children. Type 2 diabetes, on the other hand, is a disease that happens as you begin to age. We're seeing it in younger people, but classically it was sort of older people, and in particular sort of obese people, develop a thing called insulin resistance. They don't respond to insulin quite so well. Whereas type 1 diabetes, you actually destroy the cells that produce insulin. So they're two different diseases, and they have very different sort of, we would say phenotypes, but very different patients. So the classic type 1 diabetic is a relatively young child that experiences muscle wasting, and that's how it's picked out. Whereas classic type 2 diabetic is somebody that's perhaps overweight, might smoke or have a stressful job, and is something you develop sort of into older age.
So is type 1 the one where you inject insulin?
Yes, yeah, and you can, in terms of type 2 diabetes, end up having to inject insulin, but in most cases it's more about the sensitivity to insulin inside the body, so there are things you can do to sort of treat that, and you want to improve sensitivity to insulin inside the body. So we're going through this period of sort of an explosion in terms of the number of diabetics. So all these statistics are taken from Diabetes UK, which is our biggest charity for funding diabetes research, and then Diabetes, which is the biggest US charity. So since 1996, diabetes in the UK has risen from 1.4 million to 3.2 million. Diabetes prevalence in the UK is estimated to rise to 5 million by 2025. So that's 6% of the population. Majority of adults have type 2 diabetes, so 90% have type 2 diabetes, and it's strongly linked to obesity. So at the moment, the cost is estimated to be £173 million per week in terms of, I should have checked with these figures. I don't think that's all figures sort of in terms of National Health Service, but that's sort of to the UK economy in terms of these diabetes.
So is the majority of adults, of all adults?
Yes, yeah.
90% of the people in this room?
No.
No, that's not, yeah.
Sorry.
The majority is 6%.
Don't panic. So the majority of adults with diabetes, it should say, have 90% have type 2 diabetes, and it's a smaller proportion. I think about 7-8% have type 1 diabetes, and then the other people have a known form of diabetes, somewhere between the two, or rare genetic forms of diabetes. So the risk factors for type 2 diabetes are high body mass index. So to put it crudely, the more obese you are, the more likely you are to develop type 2 diabetes. So this is a figure taken from Diabetes UK to make us look at our body mass index. If you're not familiar with the body mass index, you work out your weight in kilos, you work out your height, you square your height, and then it's the weight divided by the square of your height. So if you turn out to be above 30 kilograms per metre squared, you're classed as obese. The problem is, if you look at most body shapes, they don't work out, it doesn't work out for all. BMI works nicely for people that are in the middle of heights, but if you're particularly short, you're going to be classed as obese. Most rugby players are classed as obese just because of their muscle bulk and things, and their weight in particular associated with this. So, yeah, if you took everybody sort of in the England rugby team, they would probably all be classed as obese. In terms of other risk factors, high blood pressure and high cholesterol are known to be linked into type 2 diabetes. However, there's good and bad cholesterol in terms of where we find that cholesterol inside the body, so we're still sort of understanding that. And also close family members, so if you have a family member that's developed type 2 diabetes, there is a genetic component. The thing is though, the genetic component is relatively small, so if you look at everybody's individual risk and you were to sort of factor that out into different components, at least the genes that we know about at the moment explain a relatively small amount of that relative risk. By far the biggest component is our interaction with the environment, and probably the biggest component of that is our interaction with our food and with diet in terms of developing type 2 diabetes. But there are certain populations that are particularly predisposed to developing type 2 diabetes. So in particular, people from Bangladesh and Pakistan and the Indian subcontinent seem to be predisposed to developing type 2 diabetes. There are also populations in America, the Pima Indians were predisposed to type 2 diabetes. And this has led people to come up with a hypothesis called the Thrifty Genotype. So the idea is that if you've been in a population where you haven't been exposed to things like Big Macs and Coca-Cola until relatively recently, your genes are actually set up for times of famine and conserving calories, whereas most Caucasians seem to be relatively good at getting rid of calories. So you see in these populations, they have a higher sort of genetic predisposition to developing type 2 diabetes as well.
When you say predisposition, is that in the UK or in those countries in question?
Depends on the population, but both. They have a much higher predisposition when they come. You can do. There's been some nice studies where people have looked at diet switches, where you've looked at population. So the classic one to look at is actually Japanese population, because they come from actually, what's considered nutritionally a very healthy diet. You take them, put them. You look at populations that move to the US, and you see what happens when they're put on what you might class as a more Western diet, and you see that relative risks then of certain diseases increase or decrease associated with the diet. And in the case of the Japanese, there's a marked increase in type 2 diabetes, obesity, and other forms of cancer. So they're actually sort of pretty good ways of sort of testing whether diet has an impact in terms of an association, because of course there are other things that are going on in those populations as well. There are certain populations though, the Pima Indians, they're found in just north of Mexico, so they're in the US, and they're being exposed to Western diets there, and they have horrendous sort of figures for type 2 diabetes. So, the Western diet has sort of crept into there, as it were.
Wasn't there some suggestion that at least with the British Asian population, it was the sunshine and therefore vitamin D was a factor?
I've heard it suggested. We're not researching into that ourselves. There are other things that we've been looking at in terms of, there's quite a different ratio of cholesterol in terms of where the cholesterol is found in terms of VLDL and LDL. So we've been interested in the cholesterol story around sort of how people from Pakistan handle cholesterol. So, but it is difficult to disentangle all these things when you take somebody from one area to another area, because you're not really doing a controlled experiment in some ways during these things, and you just end up with an association rather a true correlation. And the other component in terms of developing obesity and type 2 diabetes is whether you've had gestational diabetes, so that seems to increase your likelihood of developing type 2 diabetes. The biggest predictor...
So what does gestational mean?
During pregnancy. So certain women, we don't really understand sort of why it happens, but certain women will develop type 2 diabetes during that process. You're more likely to get gestational diabetes if you've had it once, and we don't know the mechanism behind why that insulin resistance sort of arises, but they're also more likely to develop sort of type 2 diabetes. But in many ways, women are protected from cardiovascular disease, so there are positives. So one of the strange things is the consequences of type 2 diabetes is that people don't tend to die from type 2 diabetes per se. So most people with type 2 diabetes will die from cardiovascular disease, either microvascular disease or macrovascular disease. Put bluntly, it's furring up of the arteries and things. It's developing things like atherosclerosis. So it's actually the cardiovascular impact of type 2 diabetes rather than the type 2 diabetes itself. A smaller proportion develop heart disease, so the heart will develop a thing called diabetic cardiomyopathy and won't function quite so well. We don't understand why the heart develops diabetic cardiomyopathy. And then increasingly we're also seeing people develop fatty liver disease and then go on to develop liver cirrhosis. So it's not so much the type 2 diabetes, but the type 2 diabetes really is the cause of all these subsequent sort of downstream diseases.
Do you find that the BMI threshold, does that decrease significantly as you get older?
Our BMIs do increase as we get older. And you mean sort of your BMI for developing sort of yeah, well I think the answer is yes to that. A lot of the time people are trying to cancel out the age of the person, seeing whether it's an aging effect or whether it's a BMI effect, but there is an interaction between the two of those things. I'll show you some data though at the end about total deaths, and you'll see that BMI does something interesting as you age, and it's probably a positive message if you're a bit older and a bit overweight. It was for me anyway. So, so my real worry with sort of doing this talk is it was just skeptics in a pub, and I think my final message, sort of in terms of diabetes and obesity risk, is actually one that's fairly obvious. So I was getting a bit worried. And on the base of it, and our problem with actually getting research funding is that the problem with obesity and type 2 diabetes, everybody's aware it's bad for us, but the solution is really quite simple. The solution is all based around the first law of thermodynamics. So if you eat 5 units and only 4 units are used in terms of energy production, we're going to store 1 unit of energy in terms of this body. So it's really quite obvious sort of why people end up becoming obese, and then we have all these negative effects. So, and for the majority of us, we're eating more foods which are particularly high in calories, they're calorie dense, and we're exercising less. And we just need to address that as a nation. 2 problems with that though, is you tell people to do this and of course they don't do it, so we do need to have treatments for people with obesity and type 2 diabetes, because people aren't going to eat less and exercise more necessarily. And the other thing is that BMI is only a good measure at population level. We all know someone that's the exception to this, that there are people out there that don't have particular high BMIs but will develop type 2 diabetes. There are people out there with very high BMIs that don't develop type 2 diabetes. And a notable exception to this is actually sumo wrestlers appear to be protected from developing type 2 diabetes. They're clearly obese by any standard, but at least while they're practicing athletes, they don't develop type 2 diabetes. It's thought to be down to some of the explosive exercise that they do. It's used to break down glucose and it's thought to be sort of protective. So I thought this was appropriate in terms of the body mass index. And like I say, actually don't get too paranoid about body mass indexes. It works very well for people that are in the middle of the range and there aren't athletes, but if you're particularly tall and if you're a rugby player, it doesn't work. And if you're short, it doesn't work either. It doesn't work for mice as well. So if you're a short mouse, you look like you're an obese mouse as well. So on the face of it, it's pretty straightforward. We need to eat less. It's not that simple. We can't always help how much we eat. And just wanted to illustrate it with this mouse. This is an Obi mouse. It's not genetically modified, if I remember correctly. It was actually produced out of a random mating scheme. The mouse doesn't produce a hormone called leptin. And leptin is very important for your appetite. And if you don't produce leptin, you basically binge eat, and you can't help but binge eat because you're always feeling hungry. And that's what happens to these mice. These mice will eat themselves, first of all, into obesity, then they'll eat themselves into type 2 diabetes as a result of this, and end up with large amounts of the sort of fat associated with them. Interestingly, they can actually live sort of a reasonable length of time. So your average mouse lives about 2 years. These guys, when they're on a carbohydrate diet, a chow diet, will probably go out to about 15 months. So it's not bad, you know. Put them on a high-fat diet, and they'll only go up to about 12 months, 13 months. So there is differences in terms of diets and things. So are the diets that are worse for us? Saturated fat. So we've known for some time that fat contributes to obesity, but actually we still don't quite know why. Well, we know why fat contributes to obesity, but we don't really know why fat then contributes to things like type 2 diabetes. And it's an active area of research, is trying to understand what some of the detrimental effects of fat are inside of the cell in terms of why the cell doesn't function sort of normally after it. One of the problems with fat is it's a high energy, dense food substance. So I'm originally a chemist, and basically fats consist of CH2 units. There's a lot of energy that's absorbed into there. You see CH2 units in petrol, and you know, in your fats, it's about as sort of as dense as storing that. You also don't need to store a lot of water alongside with fats, and I'll come on to why that's important for diets later on, and why the start of the diet sounds like everything's going well, and towards, you know, as the diet progresses, it becomes a bit more difficult to shift weight sort of further on. So one of the problems with fats is it's a high energy, dense food substance, and we have to store it. I should say this is our white adipose tissue here. So this is what your fat looks like. These are fat cells, and they have a big blob of fat sort of right in the middle of there. But you know, at the same time, these are the things that get you through the night, as it were. They are an important energy reserve. So if you skip a meal, these are the things that are going to keep you going.